Okay, so let's continue. Question number 19. How does double hashing solve collision? So in double hashing, increments for the probing sequence are computed using a second hash function. So when the key cannot be inserted because of a collision using the first hash function, then that's the time that we will make use of the second hash function. Make sure that the second hash function does not evaluate to 0 and it should not be equal to the first hash function. Number 20. Given table size of 11 and insert sequence 58, 14, 91, and 25, demonstrate the closed hash table using double hashing with the first hash function, the standard hash function, and the second hash function, 7 minus x modulo 7. Okay. So here our table size is 11 and the first key to be inserted is 58. So 58 modulo 11 will give us 3. So we will insert 58 in index 3. Okay, just ignore the line there. Then 14 modulo 11 will also give you index 3. And that's our first collision. So we will now use the second hash function. So by the way, how did we get index 7 here? So since our table size is 11, we will just get the next smallest prime number, and that is 7. Okay, so going back, since the first hash function did not work when inserting key 14, so we will use this one. So we have 14 mod 7, and that will give you 7 minus 0 equals 7. So since the supposedly index is 3 and it's occupied, we will just add 7 cells from the supposedly index, and that is index 10. So we will insert index 14 in index 10. Okay, next is 91. So 91 modulo 11 is also index 3 and it's occupied. So we will use the second hash function. And 7 minus 91 modulo 7 is also 7 minus 0 equals 7. And index 10 is already occupied by key 14. So the next step would be to multiply 7 by 2. So meaning to say, we will insert key 91 in the 14th cell from the supposedly index, which is index 3. The 7th cell is 10, so we'll add another 7 and we will find index 6 empty. So we will put key 91 in index 6. Okay. Now supposing just for an example that index 6 is occupied, then we will multiply 7 by 3 until we find an empty cell. Okay. Then the last key to be inserted is 25. So 25 modulo 11 will also give you index 3. So we will use now the second hash function, and that is 7 minus 25 mod 7. Okay. So 25 mod 7 will give you what? Will give you 4. Okay, so you have 7 minus 4 is equal to 3. Okay, then since the third cell from the supposedly index is already occupied, and that's index 6, so we multiply 3 by 2. So meaning to say, we will insert 25 in the 6th cell from the supposedly index, and that's index 9. Okay, so we will insert 25 here. Okay, and that's how double hashing works. So it gets messy with all the lines there, and I have no idea why the lines keep coming up. Okay, question 21. Suppose that the current hash table looks like below. Okay, so the hash table has a table size of 7. And then you are asked to rehash the keys 8, 0, 25, 17, and 7 into a new hash table using quadratic probing. Okay. The first step would be to determine what would be the new size of our hash table. So since the original hash table is 7, then the new hash table would be 17. How did we get 17 as the new hash table size? Now, so since it's 7, just multiply it by 2, 14. But 14 is not prime. So you get the next smallest prime number, and that's 17. So that's how we get the table size of 17. And now we can rehash the keys 8, 0, 25, 17, and 7. So 8 modulo 17 is 8. So we'll just put 8 there. 0 modulo 17 is 0. So we'll put 0 there. And 25 modulo 17 is 8. And since 8 is already occupied, using quadratic probing, we'll try first the next cell if it's empty. And since it's empty, so it's safe to put 25 here. Then 17 modulo 17 is 0. And 0 is already taken. So we'll put 17 in the next cell, which is empty. Okay. Then 7 modulo 17 is 7. And 7 is empty. So we'll put 7 there. And that will be the result of our new hash table with the keys being rehashed. Number 22. When do you implement rehashing? So we rehash only when the table is already half full, because that's the time when the insertion already fails, or when the table reaches a certain load factor. Number 23. When do you use extendable hashing, and what is the idea behind it? So when the amount of data is too large to fit in main memory, we use extendable hashing. The idea is to use directory of pointers to buckets or blocks, and then double the directory by splitting the bucket that overflowed.